today we're going to start something called implicit differentiation, which sounds super fancy. It's really not that hard, but it's nice to impress your family. When you tell them that's what you started in school, they'll think you're wicked smart. Let's look at the first one out there on your notes. It says to get y by itself and then find dy over dx. So two things we need to do. The first thing, that's bad, get y by itself. How do you get y by itself? Yeah, we divide both sides by x. Then we're finding dy over dx. That means the derivative of y with respect to x. So we're finding the derivative. So why don't we rewrite this as -1 times x to the -1 so that we can use the power rule. You guys remember that? So we have -1 times -1 is a +1, which I don't need to write, times x to the -2. Are we allowed to leave it that way? No, they did not give us any negative exponents, so we probably need to fix that. And we need to say 1 over x squared. And that's our answer. And that's old stuff. That's what we've been doing. Introduction to implicit differentiation. All right, when you look at this little symbol here on the left, this d over dx, that means find the derivative with respect to x. Well, we don't have to do anything fancy. We don't have to do anything crazy. This is power rule. So what's the answer? 4x cubed. Not a big deal. Do you guys remember when we used to do U substitution? We talked a little bit about that when we talked about M&Ms and doing a function inside of a function. And remember that if it said, for example, u to the 4th, the derivative of that, we would say 4u cubed, and then what would you have to do? We'd have to also find the derivative of u, because u is something. It could be x squared, it could be 1 minus x squared, it could be whatever, but you'd have to find the derivative of u. So I'm just going to put u prime because we don't really know what that is. It's a chain rule is what's happening. You have the derivative of the outer function times the derivative of the inner function. They're going to give you some other letters today, namely y. Y is something, we don't know what it is, but they want us to find the derivative with respect to x, not y. I don't have any x's. So what I'm going to have to do is derivative of the outer function, so 4y cubed, times the derivative of the inner function. Well, we don't know what y is, so I'm just going to put derivative of y prime. And that is the answer. It looks weird. That's it. Now, here's the thing. Mrs. Zangmore across the hall, when you guys have her next year, she uses y primes for everything. You get to college, your professor might write it like this all the time. These two things mean the same thing. This means the derivative of y. This means the derivative of y with respect to x. They mean the same thing. You'll see both in the back of the book. I haven't even looked, but I bet they use dy over dx. So just know that you can write either one of those and I will count it right. On a test, if I give you a question, it might look like this, it might look like this. You need to know that they both mean the same thing. Alrighty, so you'll see me kind of flip back and forth a little bit. What would be the advantage of using dy over dx instead of y prime? Yeah, it totally looks like y to the first power. Also, if you're kind of super speedy or a little bit messy, you might forget and you might just put y. And that's really going to mess up your entire answer and it's not going to be correct at all. So you really want to be careful on that. Let's look at the next one. Finding the derivative with respect to x. You have two terms. So just like 2 weeks ago when we were last here, we'd say the derivative of our first term is 1, right? Plus the derivative of our second term. What's the 5? And what else? Derivative of y. Good, y prime. Because you're finding the derivative of the outer function, which is 5, times the derivative of the inner function. I don't know what it is, so I just call it derivative of y. You could also write this as y plus 5 times dy over dx. Either way, they're both the same answer. Let's look at the next one. Before you start to work that out, don't forget, we have a product here. So we have to use the product rule. So we say first times the derivative of the second, which in this case is just dy over dx, or y prime, plus second times the derivative of the first, which is 3x squared. I would probably choose to rewrite this. I would call this x cubed dy dx plus 3x squared y, because that's kind of the correct order to write that in. And that is your answer. Or you could put y prime there. Same thing. Same thing. All right, let's look at the next one. Haven't we seen this before? This is the exact same thing as the first problem, but we're going to use implicit differentiation this time. They want us to find the derivative of y with respect to x. Rather than getting y by itself, we're going to use implicit differentiation. So on the left-hand side, we have a product. So we have first times the derivative of the second plus the second times the derivative of the first equals, what's the derivative of -1? 0. Whatever you do to one side of the equation, you have to do to both sides. Now here's the thing, we found the derivative, but we're not done. It wants to find the derivative of y with respect to x, meaning get y prime by itself. So I have xy prime equals -y, because I'm subtracting y from both sides. And then to get y prime by itself, we divide both sides by x. And our answer should match what we got up top, does it? Not visually. Something's up. What's the deal? This is -y. What is y? Isn't it -1 over x? Over x. If you work all that out, you get 1 over x squared. No. This is the answer. This is the one that they asked for. That's what they want. So your answers will have x's and y's in them today. All right, let's scooch down. And yeah, we could get y by itself, and we could get y by itself on this one, but it's going to get a little bit messier. So I say let's use implicit differentiation. Finding the derivative of y with respect to x. So the derivative of the first term is 2x plus, what's the derivative of the second term? 2y, I heard it, times y prime. Yes, we have the derivative of the outside, so 2y times the derivative of the inner function, which is just y prime. We don't know what it is. Derivative of 9 is 0. You have to get y prime by itself. So we say 2y, y prime equals -2x. We're subtracting 2x from both sides. Divide both sides by 2y. Whoops, I wrote 2y, my bad. So that we get -x over y. You have to divide a 2 out of both. How are we doing? Questions? Are we okay? Yes, ma'am. That's an equal sign. Sorry. My bad. Sorry. Good question. I just have terrible handwriting. Next page. Now, this is where you have to use implicit differentiation. I would say nobody in here probably knows how to get y by itself to find the derivative. And I'd say even if you did, it'd be really gross. So we have to use implicit on this one. So let's find the derivative with respect to x. So the first term is going to be what? 3x squared minus, what happens here? Product rule. You're multiplying two things. So we have first times the derivative of the second I didn't write y prime, I just wrote dy over dx. I changed it up on you, sorry. Plus second times the derivative of the first, which is going to be 6x. Plus derivative of the third term. We have another product. So we have first times the derivative of the second. What is the derivative of the second? 2y times y prime, or dy over dx is how I started, so I need to finish it that way, sorry. Plus second times the derivative of the first, which is going to be 2. Equals, derivative of 12 is 0. Let me zoom out just a little bit. You guys can see some of that. All right, we want to get the dy over dx, the y prime, by itself. Let's simplify some of this. So I've got 3x squared. I'm going to distribute this negative to everybody. So I have negative 3x squared dy over dx plus 6x, or not plus 6xy, how about minus 6xy? Hey, how'd it go? I put plus, I meant minus, sorry. Plus, I've got 2 times 2, so that's going to be a 4x times y times dy over dx plus 2y squared equals 0. Okay, I want the dy over dx by itself. What do I do? Yeah, I think what we need to do is this guy needs to go to the other side, this guy needs to go to the other side, and this guy needs to go to the other side. So let's just leave the terms here that already have the dy dx. So I subtract 3x squared from both sides. I add 6xy to both sides. And I subtract 2y squared from both sides. Heather, I know this looks crazy. It's really not that bad. Now what? Yeah. Smarties. I love that. Nobody got that first hour. So dy, to be fair, they were probably still a little bit sleepy coming back from spring break, first hour. But yes. We take out the dy dx out of both of them. So that I have negative 3x squared plus 4xy on the inside. Then what are you going to do? Divide, right? So that I have dy over dx is by itself, and then I have nastiness. Negative 3x squared plus 6xy minus 2y squared over negative 3x squared plus 4xy. And what? Now what?
Box it.
Yeah, he's right. Box it. You cannot do anything else with that. And some of you are going, well, why didn't you take negative 3 out of the first 2 terms? Because whatever you do to one part, you have to do to all of the parts. And you've got 5 terms here, and none of them have anything in common. So you're done. All right, the little box underneath, common steps for implicit differentiation. This doesn't work every time, but more times than not, this is going to get you there. You differentiate both sides of the equation with respect to x. Collect all of your y primes, or dy over dx, all on one side. We did that. We factored out a y prime, then we solved. Questions? Everybody okay? All right, let's move on. Find the slope of the tangent line at the given point, then find the equation of the line tangent to the graph at the given point. We've been doing this since the beginning of the chapter. But now they're throwing in that extra letter and making it a little tricky. It'd be really hard to get y by itself over here, wouldn't it? Be kind of tricky, and you'd have to know some identities, which I know you don't know. So let's see here. Let's find our derivative, and we're going to use kind of the method we've been using, implicit differentiation. We're going to differentiate both sides. What is the derivative of tangent? I heard it, secant squared of whatever we're taking the derivative of here. So we've got secant squared, but we have a function in another function. So that times the derivative of the inner function. The derivative of x is 1 plus the derivative of y. I'm going to put y prime because we don't know. Equals, what's the derivative of x? 1. Okay, stop for just a moment. Every other time we've done this problem, it's been a y on the left-hand side, and it's been y prime equals bleh, and then once we get that stuff, we just plug in the x, right? If you want to get y prime by itself right now, go for it. But can't you also just plug it in now? Yeah, we could also just plug it in now. It's not going to matter. It's all just being rearranged. Problem is I've got x's and y's. Good news is they gave you an x and a y. Yeah. So let's plug in a 0 everywhere you see an x, and a 0 everywhere you see a y. What do I do for y prime? It's still y prime. Means derivative of y. It doesn't mean y itself. Whoops, that's a 1. Secant squared of 0. In case you forgot, here's your picture. Here's 0. That point is 1 comma 0. Cosine comma sine. Secant is the reciprocal of cosine. So what's the reciprocal of 1? 1. So I have 1 plus 1. Wait a minute. Times. Thank you. I was like, something's wrong here. Thank you. That's a big O times sign. So we can leave off this guy. Subtract 1 from both sides. We get 0. 1 times anything is itself, so it's kind of like it's not there. Subtract 1 from both sides and you get 0. What did we just find? The slope. Derivative is fancy for slope, so we found the slope, which is what they asked for. They also asked for the equation. So we have y minus the y they gave us equals the slope we figured out times x minus the x they gave us. This one we probably shouldn't really leave that way. It's a whole bunch of zeros. Simplify that out, you get y equals 0. Questions? Last one. I would love it if you would tune me out and work ahead. Try it by yourself. I'm going to keep talking because some of y'all need that, and that's okay too. Same kind of problem. We need to find the derivative. It's got some crazy stuff going on. I would much rather solve this thing implicitly. It's going to take less time. So I've got a product. So I have first times the derivative of the second. So y prime plus the second factor times the derivative of the first, which is 2x, equals the derivative of 8, which is 0. I'm going to go ahead and plug in my x's and my y's now. I don't have to, but I'm going to save some time and space. So everywhere I see an x, I'm going to put a 2. The y prime stays y prime. Everywhere I see a y, I'm going to put a 1. And now I'm going to solve for y prime. Getting y prime by itself means that I've got my slope. And now you just write the equation. Y minus the y they gave me equals the slope I figured out times x minus the x they gave me. And there's my equation. Any questions? Okay, now you can amaze your friends and say you know how to do implicit differentiation because it sounds really hard. All your assignment is on a worksheet today. Yeah, you can do your book today. I'm going to let you pass those out.